Welcome back to another night of algebra with Miss Sackno, and we are going to be looking at the probability of compound events. Here I have 10 cards, and each of them has a different letter on them. Now I want to know what is the probability that I'm randomly going to draw an R if I shuffled all of these up. The probability of drawing an R is how many R's I have out of the total number of cards. So I have 2 R's and I have 10 cards. Now when you find probability, make sure you reduce this all the way. So 2 and 10 are both divisible by 2, so that reduces to 1/5. So I have a 1 in 5 chance of drawing an R. You can also express probability as a percent. 1/5 is 0.2, and I turn that into a percent by multiplying by 100. My decimal moves 2 places, and I'm going to get 20%. So 1/5, or a 20% shot of drawing an R. Well, now let's say that I draw an R and I replace it. I want to know what the chances I'm going to draw an R again. Well, again, my probability of drawing an R if I replace the first one I drew is still the number of R's in my deck over my total number. And how many R's do I have? Well, I put the other one back, so I still have 2. I reshuffle. I still have 10 cards. It's still 1/5, or 20%. Well, what if I don't replace it? What if my R goes away? If I take my R out, the probability of me drawing a second R is lower now. Now I only have 1 R in my deck, and I only have 9 cards in my hand. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this one is not in my deck. So now I have a 1 in 9 shot of drawing an R. Now let's look at another one. What is the probability of me drawing an A? Do this one on your own and let's check. Good, welcome back. Hopefully you got 1 out of 10 because there is only 1 A out of my 10 cards. This is also a 10% probability. All right, what is the probability of drawing an M? Good, I hope you said it's 3/10 because I have 3 M's in my deck out of the 10 cards. Good. Now, what if I want to know what is the probability of drawing an M after I've already drawn one and I don't replace it? This M goes away. How many cards do I have in my deck now? I have only 9 because this one went away. I didn't replace it. How many M's do I have? I have 2. So this is the probability of drawing one if I don't replace it. So when I'm talking about compound events, I'm talking about things that may or may not affect another choice. If I replace a card when I'm done, then my number stays the same. I still have 10 in my deck. If I still have 10 in my deck and I'm replacing the cards when I take them, these are independent events. Independent meaning they don't really affect, one does not affect the other. If I take the card out and I don't replace it, I change my deck. I go from 10 to having 9. I don't replace my card, then honestly, the one that I chose has an effect on my probability of whatever I choose next because it's only out of 9. This is a dependent type of scenario, and you're going to look at how this works with a couple of other examples. All right, let's look at this event here. Suppose I have a pink dice and a blue dice, and I want to know what the probability is that I'm going to roll a pink 3 and any even number on a blue. So let's think about this. What is the probability, my pink probability, of rolling a 3 on my pink dice? Well, how many numbers are on a dice? If you need to go ask your parents or go find one, go find one. Oh, yeah, that's right. Good. I have 6 potential numbers on a dice. So if I want to roll a 3, how many 3s are on a dice? There's only 1 3. And how many numbers total could I roll on a dice? 6. Okay, so I have a 1 in 6 shot of rolling a pink 3. But I also need to figure out what's the probability of rolling any even number on my blue dice. And when I think about this, how many even numbers do I have? Well, I've got 2, 4, and 6. So there are 3 options that I could roll out of a total of 6 options on my dice. Now, this is where it's interesting. Is this independent or dependent? If I roll my pink dice, does my pink dice affect my blue dice? No. If I roll my pink dice, is that going to change the number of options I have on my blue dice? No, my blue dice still has 6, and I could still roll any one of those 6. So these are independent. They are not related. So because these are independent events, there's a mathematical rule that says that if I want to know the probability of A and B, if A and B are independent, then I have to take the probability of A and I have to multiply it by the probability of B. Okay, A was I want to roll a number on my pink dice, and B is I want to roll a number on my blue dice. They don't affect each other, they're independent, so I'm going to end up multiplying the probabilities. So my pink probability was 1/6, and I'm going to multiply that by my blue probability, which was 3/6. And then that equals 3 times 1 is 3. 6 times 6 is 36. You just multiply straight across when we multiply fractions. All right, but I can divide these by 3, so I can simplify this. And my probability is 1/12. I have a 1 in 12 shot of rolling both a 3 on my pink and any even number on my blue. Let's do a similar one. Suppose I roll a pink cube and a blue cube again. This time, I want to know what is the probability that I'm going to roll a 5 on my pink cube, and that and is important, and that I roll a 1 or a 2 on my blue cube. Well, let's look at this. The probability of 5 is what? I have 1 option out of 6. Good. Probability of 1 out of 2. How many 1s do I have on my dice? I have 1. How many 2s? I have 2. So how many options are 1 or 2? I have 2 options I could roll out of 6 total on my blue. This simplifies to 1 and 3. I have a 1 in 3 probability of rolling either a 1 or a 2. And because I want the probability of 2 different events, this is the probability of A, a 5, and either a 1 or 2. And these are independent events. I'm going to take the probability of a 5, and I'm going to multiply that by the probability of my 1 or 2. What do you got? Good. Hopefully you got 1/6, and you multiplied that by 1/3, and you got 1/18. That's a really low probability, guys. I have a 1 in 18 shots of actually rolling a 1 or a 2 and a 5 together. All right, these are independent. They don't affect each other. Let's look at a dependent event.